Hello, Dr. Jarrah. Saif and Jamil here. So this is our project, the final product of our project, which was designing a cruise control system for a car. We got a remote control car disassembler so that we can use its shaft and its gearbox, and then we use the motor provided to us in the mechatronics kit with the H-bridge, which controls the direction of the motor, and the motor is connected to a differential gearbox here. The Myrio is controlling through our LabVIEW system, so it's the controller, and we have the whole system powered by a battery pack.
For the purpose of this this presentation, we're going to be first running the car on the flat table without the ramp, just to show how it runs on a clean flat surface. Then we're going to be doing different variations of either going up the ramp, down the ramp, or reverse down the ramp to show the different outputs of the graph. For the first trial, we're going to be running the car at 150 RPM on a flat surface. As you can see, because of the gearbox, the car moves pretty slow, but the transfer function is pretty stable. It looks like it's very jumpy, but this is because the scale has changed to accommodate for the change in variation. Now this presentation will be showing how we can change the value of the speed while it's still operating and still maintain accuracy. So as you can see, this red line marks a set point, and after the initial overshoot, the system stabilizes around the set point. And now Jamil can change the value from 150 to 200, and you can see the response. This is the set point again for the 200, and then it stabilizes pretty fast. And that's the car moving.
So if you realized in the previous segment of our video, we had a big initial overshoot. And that's because our system starts off at 100, as you see here. Here our system is not working, so it starts off at 100 to overcome any torque and then stabilizes towards the reference point. I'll demonstrate it here. So here you see the overshoot at 100 because it's set at 200, so it goes to 260, which is the maximum RPM, and then stabilizes and fluctuates between around 198 and 204. Wait.
Now I'll be running the car at close to the maximum RPM of the motor, which is 250 RPM up the ramp. To show it going up, here's the system response. You can see that it had a pretty quick response time. And yes, here we go. And it going down the ramp again. And as you can see here, after going down the ramp, there's initial disturbance, but then it's stabilized.
So now we're going to demonstrate the car starting off from a ramp position, and this is when our 100% beginning helps us in getting a torque. So we're going to set the reference point to around 200 to see the overshoot.
So you can see that because it started at 100, the torque helped it to prevent slipping backwards and help aid the car go over the ramp. For our final demonstration, before giving a brief LabVIEW explanation, we're going to be making it go reverse, so a negative RPM value input up the ramp. This is it's a nice experiment to do because of the fact that our car is actually front wheel drive. So we're going to be putting it up in rear wheel drive up the ramp to see how it affects the system. And you can see here, the system has pretty much, aside from the slight disturbance when it touched the ramp, it's almost stabilized after. Our input value is 200, and you can see here it's fluctuating close between 197 to 204.
So the design part of the LabVIEW, as you can see here, is the proportional constants, the proportional gain, integral time, and derivative time. We got values from MATLAB for a PI controller. However, it didn't work on our real-time system, so therefore we had to use a process of trial and error, and really the best gains we got were the gains that you see here: a proportional gain of 1, an integral time of 0.001, and the derivative time of 0.01.
Okay, Dr. Jarrah, this concludes our presentation on the cruise control car. From both Jamil and I, we'd like to say thank you for an excellent semester. We really enjoyed this project. It gave us a hands-on approach to working on all the theory and math work we've done in the control systems course. So it was a really nice hands-on application. Thank you very much.
Thank you, and good luck in the future, Professor.
Good luck. Bye.